All right. Hello, everyone. My name is Keegan Flanagan, and I am from the UBC Dynamic Brain Circuits Research Cluster. And today, me and my supervisor, Jeffrey Ledoux, will be guiding you through our ImageJ macro workshop. So without further ado, let's just jump right into it. So to start things off, I just want to tell you a little bit about our research cluster and what we do. Some of our main goals are to support interdepartmental collaboration, to promote the open sharing of research and especially the sharing of research data, and to provide training for coding analysis and data management through online resources such as workshops and talks like this one. A very special online resource that we provide is a weekly event called Data Binge. Data Binge is an online interactive meeting hosted by the cluster where people can present their coding problems to a group of coding tutors and research experts, and then they can be assigned to a Slack channel with a coding tutor to work on that problem. It is a really great way to get help with your research if you are stuck anywhere on your analysis. All right, then with the introduction out of the way, let's move on to the workshop. So the first thing we need to do is make sure that everyone has the materials for the workshop. I really hope that all of you have already done this at this point, but in case anyone came in early or anyone has not gotten around to it yet, I'm just going to go over it one more time. So please, if you have not already, go to the link I'm about to post in the chat. I will see you all there in 1 second. All right, and once you are here, please go to this section called Files, and underneath the Workshop area, click OSF Storage, and then download that as a zip file. Then go to the ImageJ example section, OSF Storage again, download as a zip file. This one is about 1 GB, the example section, so it may take a little while, but hopefully it all gets loaded up fast enough. Then after you've done that, please save them somewhere you can easily find them on your computer, like your desktop. Rename in this storage area to BIF DBC NINC ImageJ Workshop. And then rename this storage area to Examples, and then place it into the workshop folder. All right, I hope everyone has gotten a chance to gets a chance to do that, and I'm going to head back to the slides now. All right, now let's move on to macros. So what is a macro? Well, the word macro is short for macro instruction. Generally speaking, a macro is like a small script which contains a set of instructions. These instructions can then be run within a program, usually through the push of a single button. This makes macros really useful when you're trying to automate time-consuming or repetitive tasks. And these macros are usually created by recording yourself completing a series of steps on a program. Once these steps have been captured in the macro recording, you can then run the macro to replay those steps you just recorded on the program. Now, ImageJ itself comes with 300 example macros that you can look into on the ImageJ website. And I would encourage you to look over these at some point because a lot of them are really useful. But today we are going to be focusing on creating our own macros. Just to really drive home this idea of what a macro is, I'm going to give you some examples of different places where macros are used. For a first example, in Microsoft Word, you can record yourself typing something out and then automatically type out the exact same thing with the push of a button. This might be useful if you do not want to type out your entire mailing address every time you draft a letter in Word. Another example would be video games. You could turn on a macro recorder on a special controller, input some kind of sick combo, and then save that combo so you can automatically execute it with the push of a button, because you are a dirty cheater and you have no skill and you can't do it on command. Finally, in Photoshop, you can use these things called actions, which are just macros in disguise, and they can automatically alter and stylize an image just like you see here. This is what's going to be the closest to what we're actually going to be doing today. All right, so now that we know what a macro is, we are going to create a super basic macro in ImageJ just to get a feel for how recording macros works in ImageJ/Fiji. All this macro we make is going to do is take an image and rotate it 90 degrees to the right. So you guys are going to watch me create this macro first, and then I'm going to give you guys a few minutes to try to recreate the macro yourselves. So I'm going to head over to my desktop now. And bring up Fiji. And once I've brought it up, we are going to go to Plugins, Macros, Record. And from here, this will open up the Macro Recorder menu. This is where you can see all of the different actions that the macro has recorded so far. And it is also where you can rename your macro. So we are going to call this one Rotator. Once we have done that, we can get started. So I'm going to go to File, Open. I'm going to go to my desktop where I've saved my workshop folder. I will go into Examples, Single JPEG, and open the file inside. This image is just a random picture of a brain I found. It's very cool, but how this was created or what it means, it's not really important. And once we have opened this, we are going to go to Image, Transform, Rotate 90 degrees right. And that's it. That's all we'll do for this macro. So then we are going to click Create. And this will bring up this little screen here. We're going to run our macro to make sure that it works. Yeah, it does exactly what we want it to. At which point we're going to go to File, Save, and then just save it somewhere smart like our workshop folder. Then we can close these and we are all done. All right, so now I'm going to bring up the instructions on the PowerPoint again, and I'm going to let you guys work through this on your own for around 3 or 4 minutes. That should be the one.
Another question popped up about the utility of that command in the macro that opens the image.
Yeah, so we're going to talk a bit more about the open command later. One reason I choose to include it in the macro is because you can always just edit it to open up a different one. And a more important reason is that once we get to batch processing, which is applying macros to multiple images all at once, that open command is important. And once we get to that, then we're going to basically just cross that out and comment it out. And then we are just going to use something that will automatically put everything from a folder in. So we'll address that more later.
It's mainly useful for testing.
Yeah. All right. So 3 minutes have passed. Would people mind just kind of giving me, maybe putting a couple of reactions around the chat just to show me if you're done? So I can get kind of a sense of how people are doing. Okay, I'm seeing a lot of thumbs up. So I think I'm going to give it a couple more seconds and then move on. If anyone is struggling, if anyone was struggling with that, you can of course find these notes in the workshop folder, and you can feel free to work through them on your own time. All right. Now we're going to move on to showing some more interesting examples of macros. But before then, there are a few things I really want you to keep in mind when you are creating your macros. The first thing is that the macro recorder will record all of the actions you take in the program, regardless of whether you want it to or not. So you can't be randomly opening and closing things or moving things around. You have to do just what you need. The second thing to keep in mind is that all of the actions you need to complete for your task must be completed after you have already started the macro recorder. A really common mistake might be that someone opens up the image, then they work on it a little bit and get it to a certain point, and then they start the macro. But now, not everything you did is in that macro, so it's not going to work the way you intend it to. The third thing to keep in mind is that the order of your actions is saved in the macro. So if you do something in the wrong order, it will be stuck that way. And then the last thing I need to make clear is that you need to click create and then close the recorder in order to stop the macro recording. So don't complete all of the actions you need and then just forget about it and start doing something else. You need to click create, or it's going to save all the extra actions in the info. All right, and with all of that out of the way, I'm now going to turn this presentation over to Jeff so that he can give you an example of a case study that would actually require use of macros.
Okay, thanks, Keegan. So yeah, like Keegan said, the data that we're going to use and the macros that we're going to create with the rest of our workshop comes from a project that we were working on in the CBH. It involves an imaging technique called mesoscale calcium imaging. So in doing this, we make a large transcranial window so that we can have a window into the brain of a transgenic mouse. And this mouse expresses a calcium sensor. Yeah, is that better? I'll just hold my mic over to the, yeah, okay. Way better. Okay, perfect. Okay, so I was saying we have a window into the brain of these transgenic mice that express a calcium sensor in their cortex. And so calcium changes that are associated with neuronal firing result in an intensity change in fluorescence when we record these images with a simple epifluorescence scope. And this is useful for neuroscience projects because you can use these data to assess functional connectivity in the brain and the interplay between different cortical areas while an animal is doing an active behavior. This is something that we've pioneered at UBC, but it's been adopted around the world at this point. Next slide, please, Keegan.
Yeah.
Could you play the video? Does it start automatically? Okay, thanks. Yeah, so Keegan has just started playing a video of one of these recordings. So at the top of the recording, that's the anterior part of the brain. The bottom is the posterior. You can see the midline in the middle separating the two hemispheres. And hopefully over Zoom, you can see some of the green intensity is fluctuating. And this is the signal that we're wanting to quantify in these experiments. But usually it's a small change in fluorescence. So we calculate something called delta F over F, which is just the fractional change in the fluorescence as a function of time. That helps us visualize these small changes more easily. So if you look at the panel below where the movie was playing, there's a time course of an experiment. There's a bracketed region on that timeline where the animal receives some water. And you can see the processed images below. We can see this large activation in the cortex that happens in the anterior part when the water hits the animal's tongue. And so to go from the raw data to these kind of montages that we would present in our publications, we need to do some image processing to calculate the delta F over F for a particular piece of data. Next slide, please.
All right.
So these experiments are very useful, provide interesting data, but they're also very time consuming. So we embarked on this experimental automation project to try and let the mice essentially run the experiment without intervention from the investigator. So we built these little imaging chambers that get attached to the animal's cage that you can see on the slide here. The animal is wearing a special bar that fits into a groove in the chamber, and they walk to the end of the chamber, and they're fixed in place there, and a blue excitation LED comes on, and we record the images as you saw with the camera above while the animal is drinking the water. So this is also something that a lot of different labs are toying with now. There's a link in the slides to the paper that we published if you want to check it out. Next slide, Keegan. But what this means is, since this is happening 24/7 unsupervised, you get hundreds of recordings from when the mice decide they'd like to go and drink the water that you haven't been present while the images are acquired. So we need to do some kind of quality control on these recordings, and there's a lot of them. So I would say the data is definitely big enough that automation is needed just to keep up with it. And this is where the ImageJ macro comes in. And this is in fact what I did to do quality control when we were doing these experiments. I would process each day's recordings with an ImageJ macro to decide if anything had gone amiss the day before. I think that's it for me, Keegan.
All right. Thank you so much, Jeff. So now that we know a little bit of background, we are actually going to create a macro that is going to automatically calculate DFF for some mesoscale calcium imaged mouse brains. The images from the mesoscale calcium imaging are going to be in the form of XYT stacks. For those of you who are not familiar, XYT stacks are basically just a series of images that were taken over time. You can think of them like the frames of a video all collected together into a stack. And now we are going to create our macro by simply turning on the macro recorder and then manually calculating DFF step by step for some of our stacks. The macro recorder is going to record all of our actions so that we can then just repeat them with the click of a button. Then, once we have created our macro, we are going to use it to automatically calculate DFF for 5 other stacks using ImageJ's built-in batch process functionality. Now, all of that sounds well and good, but first we need to figure out how we actually calculate DFF for images. And we are going to be calculating the DFF for our images using image arithmetic. I imagine that some of you have heard of image arithmetic before, but for many of you, the idea of adding and subtracting and performing basic operations on images or stacks might be new and it might seem kind of strange. The way it works is that when we have an electronic image, that image is made up of many different pixels, with each of these pixels having a pixel value that describes how bright that pixel is, just as Miki said earlier. So what image arithmetic does is it compares 2 or more images on a pixel by pixel basis and performs the chosen operation on each pair of pixel values. So as an example, you can see down here that we have two identical images and we add them together to create a third image that is twice as bright as the original two. So now that you know about image arithmetic, the way in which we can calculate DFF for our stacks should be coming together. We can just use this equation for DFF we saw earlier, combined with image arithmetic, to calculate the DFF for every pixel in one of our images, which will allow us to visualize DFF across the entire brain. Let's go into some more detail on how this is going to work. We're going to calculate the average fluorescence for our XYT stack by creating a projection of the stack. And a projection basically means that we're taking all of the images in our stack and we're just kind of averaging all of their pixel values together and creating one kind of consensus image, an average image, essentially. And once we have done this, this will be our F0 term. And then once we have made that projection, then it's pretty simple after that point. For each image in our stack, we can subtract and divide by our projection to calculate DFF. The result of this process is that we're going to have a stack of DFF images that will show fluctuations in brain activity over time. All right, so now that we hopefully understand how we are going to be calculating DFF in ImageJ, let's actually get ImageJ set up. The first thing we are going to have to do is add a new lookup table, or LUT, to our ImageJ files. Now, we already talked a little bit about pseudo-color images at the end of the last lecture, and you hopefully all noticed that we created a pseudo-color image using a lookup table, or LUT. ImageJ has a lot of pre-packaged LUTs that we can use, but for our purposes today, we are going to be using a custom LUT. So in the workshop folder that you downloaded, you should see a file called a selfmade3.lut. And what we are going to do is we're going to drag this self-made LUT into the LUTs folder for the ImageJ application. And note that after we've done this, we're going to add a new after we've added this new LUT, we are going to have to restart ImageJ/Fiji so that we can use it. So to go into more details on how to get to this LUT folder, first I'm going to show it on Mac, where we go into our applications section for Finder, we locate Fiji, right-click it, and then choose Show Package Contents. That will open up something that should look like this, where you will be able to see a LUTs folder. You can then open this and just drag a selfmade3.lut into it. So I'm going to give all the Mac users a couple of moments just to do this, and then I'm going to move on to showing some image examples of how to do it in Windows. All right, so hopefully everyone has had a chance to add a selfmade3.lut into the LUTs folder for the Mac users. I'm now going to move over to Windows, and luckily in Windows this should be even easier. All you have to do is find wherever you have saved Fiji on your computer, then open up the folder, go into the LUTs folder, and add a selfmade3 to it. Hopefully, after a few minutes, all of you will have a selfmade3 inside of your LUT folder in one way or another. So I'm going to give you a few more minutes to do that, and I'm going to give everyone a minute to restart image/Fiji so that we can automatically use it. All right. I hope that everyone has had a chance to add a selfmade3 into their LUTs folder. If not, you should still be able to continue with the workshop. You just will have to maybe skip the last step in the macro, so it is not too disastrous. But let's move on to creating our macro now. So we are going to be setting up ImageJ just a little bit more, and we're going to take a little look at the TIFF file we are going to be working with. So I am going to move back over to my desktop. All right, so I have Fiji ImageJ brought up again, and I'm going to go to File, Open, into my workshop folder, and what is it doing now? 1 second. All right, sorry about that. So File, Open, Desktop, Workshop folder, Examples. Now going to the single TIFF file and opening up the image within it. And what you should see is a little green image of a brain like this. And you will see that this is a 256 by 256 pixel image. It is an RGB image, which just means that it is in color. And you will also see some numbers here, 1 out of 925. That is telling us how many images are in our stack. And we can actually use this little slider here to scroll through time for the stack. And you can see as you do this, little fluctuations in fluorescence as time moves on. So now we are going to create our macro to calculate DFF for this XYT stack. I'm going to go through the first couple of steps, and then I'm going to leave it to you guys to try and figure it out. I'm going to give about 3 minutes for the first page of instructions on the PowerPoint, and then another 7 minutes for the second page, as that page is quite a bit more difficult to go through. So I will close this, go to Plugins, Macros, Record. I'm going to rename this to DFF Image. That file, open that same TIFF file. And then I am going to rename this file to current. All right, and with that, I'm going to stop sharing and bring up the instructions from the PowerPoint. I'll give about 3 minutes for this first page here. And then I will switch over to the second page. Please let me know if you get stuck anywhere or if you have any questions. All right, I'm going to switch over to the second page now, and we're going to give this one about 6 minutes. Someone just asked about closing all 3 of the images without saving. And yeah, we're doing this so that when we rerun our macro, the only result of this is the completed image. If we weren't deleting those 3 images without saving them, then every time we ran the macro, all 4 of the images would show up instead of the one image that we are actually hoping to get at the end of this.
Yeah, these are really just the intermediates that you're getting as you do the calculation. So they could be saved if you really wanted to go back and examine them, but for the purpose of this macro, it was mainly for checking the quality of the data, so I could assess that from the final DFF, so I did not look at the intermediates very carefully or save them, since it would take an equal amount of disk space as the data itself.
Someone was talking about the unable to assign an LUT to an RGB image. I'll get to that second question later, but I find that sometimes happens if I forget to specify a 32-bit float result. Sorry. If I forget to specify a 32-bit float result when doing the image calculations. So I would expect that might be what happened. So if you're able to go back to that step, which unfortunately might require for you to restart, you should be able to fix it that way. I'm going to walk through this soon, so perhaps you can try again while I am walking everyone through the process. And so for image, so you should be image adjust brightness and contrast. So have you gone to adjust first?
I think the problem there might be that too many images were closed, but maybe we can catch this on Keegan's walkthrough of these steps.
Oh yeah.
Let's see if we can fix this up. Do you want to start the walkthrough, Keegan?
Yeah, I'll start the walkthrough now. I'm sorry, I guess I misunderstood the question. There should have been 4 images up at the point where you were deleting those 3 images. So let's start the walkthrough and see if we can figure out where things maybe got off track. So I will stop sharing here. And I will go back to sharing my desktop. All right, so we now have our current image up, and what we're going to do now is we're going to go to image scale, going to set this to 0.5. So now we have current -1. So from this, we are then going to close current, and we're going to go to image stacks Z project, average intensity. So now we have our average image, and this should be the second image we have up. Now we are going to go to process, image calculator, and we are going to select 32-bit float result. I'm hoping that this is what went wrong for anyone who had the error with cannot apply LUT to an RGB image. So hopefully if you remember to do this, that problem will go away. Then we are going to select subtract for our operation, put current 1 on top and average current 1 on the bottom, and hit OK. Yes. Should get something that looks like this. Now we are going to go to process, do image calculator again. And now we are going to do current, now we're going to do result of current 1 divide by average current one, again, keeping 32-bit float selected. Okay. And now we have 4 images. It's at this point where we're going to close the 3 older images, specifying that we are not saving them. So we only have the 1 image left that is going to become our final image. We then go to image, adjust, brightness/contrast. We're going to choose set, negative 0.02, 0.2. Okay. And after doing this, your image should look something like this. And now finally, we can go to the image, lookup tables, go down to our A Self-Made 3 LUT, click it, and at this point we have the image we are looking for, and we should be all done. So we can go to our recorder, click Create, and we now have our macro recorder. Our macro recorded. So let me just rerun this to make sure I did everything right. Scaling. A little different. Let me just find this sometimes. Yeah. There we go. All right, so I'm looking over the chat now that we have this completed. And Jeff, do you think you could help me with a couple of these questions? I'm not sure about the use of keystrokes rather than directly editing it.
Yeah, I'm not totally clear. Do you want to unmute Jill and tell us what you're thinking about?
Do it. So I mean, I can go in and go to macros and then choose edit, right? And then open my macro, and then I get some kind of code, like Python type code. So obviously I type stuff in there, but that's complicated compared to what we were doing with the create function, where you just pick stuff, right, and it kind of writes the code for you.
Yep.
So can I go in and use just like choosing stuff off menus to edit this, or that's not possible?
So what I've done in the past to deal with the situation you're describing, let's say we left out a step, like we forgot to do the scaling and we really wanted that in our macro. So what I would do is then just record another macro with those few steps that I want to add, and then copy and paste that code into the right place in my larger macro.
Oh, smart. Okay.
Does that make sense?
Yeah. What I did is I forgot to I didn't restart Fiji after I installed the loops, and then obviously you get to the end, it's not there, so then you have to restart, right? But that's a good solution. I like it. Thank you.
And then could you talk about how we can use it in our projects? Yeah, so I guess this delta F over F calculation is commonly done with functional indicators in general. It doesn't have to be mesoscale calcium imaging in the brain per se. It could be calcium imaging in a dish of cells, or some other indicator that also reports a change in fluorescence. So you could imagine doing this same kind of process with different types of data. Ada, does that kind of address what you're thinking about, or do you have a specific project in mind? Feel free to unmute if you like. But in general, if you have some steps that you want to do, you can do what Keegan has shown and record them in the macro, and then it's just more or less about the time saving involved. I mean, it takes quite a few clicks to do this process. You're going to get tired of it if you have hundreds of them to do. So that was the main utility in our case, was just speeding up the quality control on our data. What does it do for divide by 0 pixels? This is a good question. Keegan, maybe we can try this. Do you want to just go to File, New, and you can create an image of zeros?
Sure. I could try image.
So give it 256 by 256, same as our
6.
Yeah. And then let's see, if it's filled with black, then you hover the mouse on it. Does the ImageJ tell us it's a value 0? Yeah. Okay, so then could you open the original TIFF file?
Yeah. Open.
And then, yeah, exactly.
Divide by untitled.
And then if you hover the mouse in this resulting image, what does it tell us? There. So it looks like it's noting that this something has gone awry by reporting the value as infinity. So I think at this point we were going to go on to doing the batch processor. Is that right?
Yeah, we can move on to the batch processor now if there are no more questions.
If there are more questions, just feel free to pop them in the chat while we're doing the next part.
Yeah, absolutely. Okay. And one last thing for this is I'm just going to save it within my workshop folder. There we go. All right. Now I'm going to go back to the slides. All right, and now that we have our macro, we should be able to automatically process a single image file to obtain delta F over F by simply running our macro. If you want to use the macro on a different file other than that single TIFF file we just used, then you can process a different file by just editing the file name in the open command of your macro. But that is a little slow and clunky. And in some cases, it is very useful to use our macro on multiple files without having to do any coding or opening up files manually or changing names. And this can be done by using process batch macro or by using process multiple image processor in Fiji. Today, we're going to be using process batch macro to calculate DFF for 5 different XYT stacks all at once. And then we are going to use our new DFF stacks, and we're going to place them into an output folder. All right, so once again, I'm going to give you about 5 minutes to try to work through this on your own. If you get stuck, that's no problem. As soon as the 5 minutes are up, I'm going to do a walkthrough where I'll go through this step by step, and we can figure out any places where something may have gone wrong. All right, so I'll put about 5 minutes on the clock. All right, so 5 minutes have passed. I'm now going to start the walkthrough of this section. I hope everyone had a chance to finish it already, but if not, that is perfectly fine. Let's switch back over to desktop. All right, so now I'm going to open up my workshop folder, create a new folder named output. Then I'm going to go to process, batch, macro. For input, I'll go to my workshop folder, examples, 5 TIFF files. For output, I will go to the output folder we just created. Then I am going to open up the code I just made, the macro we just made. I'm going to copy this, paste it in, use the arrow keys to move to the top, put 2 slashes in order to comment out open, and test. So I meant to hit process there. Test will work fine just as well. All right, so this is going to take a few minutes to run through all of these scalings and redoings and stuff like that. So if anyone has any questions, now would be a good moment. All right, so one person has been having some trouble opening files onto ImageJ. Do you have any bug fixes for this maybe, Jeff? I'm not sure what would be going wrong in this situation.
Yeah, I'm thinking. Brian, do you want to unmute and tell us exactly what's happening? Like, are you trying file open?
Let's say like I'm in the ImageJ app and then sorry, let me just open it up again. So if I go file open and then like I try to open the zip folder for the workshop, it'll say like this zip archive does not appear to contain TIFF files. Yeah. But I thought there were TIFF files in there, so I wasn't sure if I needed to like save it differently or whatnot.
I think in that case, with the zip, like when you download things from Open Science Framework, it likes to pack everything in a zip.
Yeah.
But for ImageJ to reliably open stuff, you'd have to extract that zip. Kian, do you have the zip there? Could you show this process?
Yeah. On Mac, it's as simple as just clicking on it, and Mac would automatically do it. I'm not sure what you are running and how it would.
Oh, I think I see what you're talking about, like the extract. there, I do see like an extract on the top of my file explorer for Windows.
Okay. Yeah.
Like extract all.
Yeah, try that first.
Oh, okay.
And then I think ImageJ will be able to navigate inside there and find the TIFF and open it for you.
Okay, I think that will definitely solve the issue. I had another quick question, but I think
Sure.
I think Ida had a question in the chat, so maybe answer her question first and then get back to me.
Okay, sure. Don't have anything in the output folder. Keegan, have you encountered a blank output folders before?
Not unless I somehow went wrong somewhere when, for example, just entering in the output for the batch itself. Like if I had done something like specifying output and something had gone wrong here and I hadn't selected the correct folder, but I'd never really encountered a sort of a specific bug for this situation. And it's also possible that maybe they hit test instead of process, since test would just make sure it works instead of actually going through the entire batch, but I can't be sure what's going wrong in this situation.
Ada, do you have the Fiji version of ImageJ, or you have ImageJ by itself?
Okay, that's it.
Oh, the test by itself. Okay, yeah, got it.
Awesome. Are there any more questions before we start kind of wrapping up the workshop?
Yeah, I just had a second question, sorry, real quick. When I was trying to do the recording the macros, and I went on to the brightness and contrast step with the small histogram, it said that I didn't have an image, but then I think someone mentioned this in the chat earlier, but I wasn't really following along. So then I wasn't sure what I was supposed to do there, because previously I closed all 3 images and then so I don't know which image I'm using for the brightness and adjust contrast.
Yeah, so we talked about this before where you said all 3 images, but at that point you should have had 4 images, where there should have been 1 image, which was the descaled current, then there would have been the Z projection or the average, then there would have been the result from performing the subtraction, and the result from performing the division. And that last one, the result after you had completed the image division, that is the only one that would be kept, and that's where the brightness and contrast would have, that's what you would have applied it to that image. So at some point, you must have either missed one of the calculation steps or perhaps closed something too early. And that's why when you closed the 3 files, you weren't left with any other images up.
Okay, perfect. That makes so much sense. Thank you so much.
Yeah, you're very welcome. Okay, anyone else? Add all code.
I'm not sure I understand.
Could you explain more about your question, Ian?
So for the window, we saw it like a batch macro. We put the input output folder, and then you put the all macro word into the whiteboard. Instead of it, we can choose our macro. Add macro code. So we can choose it. Or maybe not.
Yeah. So these are all things that have been that are actually inside of Fiji. And if we just saved our macro to that place, then we absolutely could do it. Just for the sake of simplicity, I chose to save our macro into the workspace so that everyone knew exactly where it was. But yeah, you can definitely just
So
select
far,
macro from
yeah.
this list.
Okay, thank you.
Yeah.
I think that one is probably most useful if you have just a large number of files that you need to do 1 or 2 operations on.
Mm-hmm. All right. So I think that was every question. And I'm going to move on now to the last little bit of the macro section, though first I'm just going to quickly look at the contents of the output folder. Looks good. So now all of these, I don't know why they appear black like this, but all of these are properly processed images. All right, and now I'm going to move back to the slides to start finishing things up. Okay, so before we end today, let's go over a couple of additional resources for working with ImageJ that I would like to point out to you. Inside of your workshop folder, you should have a PDF copy of this, PowerPoint. So you can go there if you want to actually click and access any of these links. All right, and this first web page it will detail all of the macros that are actually available for ImageJ that you can just take from the ImageJ website. The second bit is documentation that describes how the ImageJ macro language actually works. This is really helpful if you want to learn how to edit a macro directly after you've already made it. Then there is the ImageJ documentation, which is great if you want to learn more about the program in general. And finally, I want to point you towards an ImageJ workshop that was created as a collaboration between the Dynamic Brain Circuits cluster and our friends at iCord. This workshop goes over some more advanced stuff, such as directly editing macro code and integrating ImageJ into Python. So if you think what we did today is a little too simple and you want to do something more advanced, I highly recommend you check this out. If you have any questions about the material in this workshop that we just went over, or if you have any difficulties with data analysis of any kind, I just want to urge you once again to attend our Data Binge meeting. We meet every Friday at 12:30 p.m. So if you would like to attend, just let Jeffrey know using this email here, and we will be happy to invite you to the DBC Slack channel where you can get an invitation to Data Binge. And finally, I just want to end with one last shameless self-advertisement. The Dynamic Brain Circuits Research Cluster has decided to team up with the BC Brain Wellness Program to host an event called Brain Tech 2021. This event is going to be a brainstorming session and hacking competition to design an app/game/package to support brain wellness. All researchers and students with any experience in life sciences or with computer science are welcome to participate. The winning teams of the event can receive up to $800 in prizes. This event will take place in 2 parts. The first would be an initial idea generator session on August 6th from 12:30 to 1:30, and the second will be the actual hackathon event, which will take place throughout the day on August 13th. Anyone who is interested in participating in the event can register from our event website, which you can find using this link right here on the slides, and then I will also be posting in the chat in just a few moments. And with that, I would like to thank you all for attending this section of the workshop today. Now I'm going to turn things over to the rest of the team for some final